Welcome to Pomodoro Joe for Saturday, May 20th, 2023. Today we're doing LeetCode problem 399, Evaluate Division. This is a medium problem. You are given an array of variable pairs, equations, and an array of real numbers, values, where equations index I is equal to a, b, and value index I represents the equation a divided by b. Each a or b is a string that represents a single variable. You are also given some queries where queries index j is equal to cd, represents the jth query where you must find the answer for c divided by j equals something. Return the answer to all queries. If a single answer cannot be determined, return -1. Note, the input is always valid. You may assume that evaluating the queries will not result in division by 0 and that there is no contradiction. All right, let's take a look at an example here because this is a little bit confusing. So we have some equations with string, okay, a, b, and b, c, and then values 2 and 3. All right, so that means that a divided by b, whatever a is, and whatever b is, that'll be 2. All right, let's write this out a little bit. So we have a divided by b is equal to 2. Well, what can we determine from this? Well, we can determine that a is equal to 2 times b, or twice b. We can also determine that b is equal to a divided by 2. Yeah, I'd say that's about all we can get out of this one. But that's interesting, that we can find that a is equal to 2b. So b can kind of be our unit value here. And so a can be equal to 2 of these unit values. We don't know what b is. It doesn't really matter. We just know that a is 2 of them. So let's look at the next one on our list. We have b and c, and that equals 3. So that's b divided by c is equal to 3. What can we get out of this one? Well, again, we can do something similar. We can say b is equal to 3 c's, or 3 times c. And we can also say that c is equal to b divided by 3, or 1/3 of a b. That means 3 c's is 1 b, which means that 3 c's times 2, 6 c's is equal to 1a. Okay, so we're kind of getting somewhere. So now down here, we have a and c. Well, we just sort of determined that c is 1/3 of a b, so 3 c's is 1b, and 2 b's are 1a, so 3 c's is 1b times 2, so 6 c's is 1a, so when we have a divided by c, that should be 6, and that does indeed give us 6. All right, next one is b divided by a. Well, that's just the inverse of this one, so that's 1/2, which is 0.5. Yep, we got 0.5. All right, so let's see what's next here. We've got a over e. Well, let's see, there is no e, so that's going to be -1. A over a, well, that's just 1, and x over x. Even though there is no x, and this should probably be 1, x could be a 0, so we just have to say it's -1. We don't actually know what x is. Okay. All right, so this is going to be tricky, but I think we can do this one. So we'll put 25 minutes on the Pomodoro timer and get started. So the first thing I'll do is get a mapping of our different values. So we'll go through these equations and we'll find every value in terms of some equation of the other value. So let's just have this mapping. And that's going to be a, let's see, we'll need to have a value and then the other value and then the factor of that value. So let's write this down. So the key will be one of these variables, and the value, well, that will be another dictionary where its key will be the other variable, and the value will be the, what will we call it, the conversion factor. Yeah, so this is what we've got. We have a mapping where the key will be one variable, and the value will be another dictionary where its key will be the other variable and the factor. So for instance, our A and B, we know that A maps to B with a conversion factor of, and what was it, 2? Yeah, we have 2. Okay, so we'll have a default dictionary of dictionaries. Okay, and then for every, let's see, we've got A and B and value. So we kind of need all 3 of those pieces. So we'll go A and B. Oh, I guess we need our index. Let's do that. For every index and length of our equations. Maybe I'll do it this way. For every index and value in the enumerated values, we'll grab A and B out of the equation. So we have A, B is equal to the equations at this index. And now we need to add these to our mapping. So let's see, our mapping for A, well, we already know that the equation here is A divided by B. So the mapping for A, well, that's going to be, we need a dictionary where we add B, and the factor will be our value. So A will be value times B. Let's go back to our equation here. So A divided by B is equal our value. So that means that A is equal to value times B. And then our mapping of B to A. B, well, that's going to be equal to our A divided by our value. And in this case, we can say it's 1 divided by the value times our A. So in that case, this will be 1 over our value. Okay, that's pretty straightforward. And then we could keep things symmetric if we want. This might make it easier, I don't really know, but we could say mapping of A to A. Well, that just gives us 1, and mapping of B to B gives us 1. So that might help us out. I don't really know yet. We'll find out later. Okay, so this builds up our mapping. So in our mapping, we can pass in one variable, and it will give us back a dictionary. We'll pass in the other variable, and that will give us some factor that we can multiply by our second variable to get our first variable. Okay, so this should eventually help us out when we start evaluating our queries. Let's see. I guess let's start evaluating our queries here. So for every query in our queries, well, we don't really have any way to evaluate these yet, so let's create some evaluation function. So let's grab our C and our D out of our query. And then we'll just call some calculate function on our C and our D. Let's get our result. So we'll call this the result. And let's see, we need to return a list of results. So we'll have some results variable here. That'll be some list. We'll get our result out here, and then we'll just append that result. So at the very end, we'll return our result. Okay, so this gives us our basics, but we still don't have this calculate. This is going to be the tricky part. All right, let's define a function here. It will take a C and a D, and it will return our calculation, which is C divided by D. Yeah, so we have to calculate C divided by D. Okay, how do we figure out our C divided by D? Well, we need to find our common factor. So if we already have some common factor, let's say this is A and B, well, we already know A divided by B. We can just look at our mapping. We can find our A in terms of our B and return that. So let's do the simple thing first here, and then we'll expand that because the simple thing won't cover all the cases. So the simple thing is, well, let's find our mapping in C. So for our mapping of C, for every key, in this mapping. So we're going to look at every key in our mapping of C. So that should be every variable that we know the factor to convert from that variable to our C. If that K is in our mapping of D, so now we have some common factor. We know C in terms of this key, and we know D in terms of this key. Then we can combine those two factors to return our value. So our value here will just be our mapping for our C at this D, or sorry, C at this key, times the mapping of our D at this key. Okay, so this is our basic calculation. If we have this common factor, then we can return the value for that common factor. We might not have a common factor though. So this will work for a simple case. It should work for this second case here. It might not work for the more complicated cases, such as this factor here. But let's try it out. Let's just see what this gives us. I need to change that to plural results. Okay, let's just see, first of all, if our K is not in our mapping, then let's return -1. Or actually, if we get to the end and we don't have any K's in our mapping, we'll return -1. Okay, let's just try this just to see if we're getting our basics working. Okay, so let's see. Case 3 actually worked. So we're getting some basics working. Case 3 looks like it's working, but case 1 and 2 don't work. What are we missing here? So A in terms of C, yeah, we don't really expect that one to work because we didn't have any common factors immediately in K and C. B and A, I kind of expected this one to work. Oh, and it did work. Looks like we got the right thing. A and C, or A and E, that also works because we don't have any E's. A and A, that's interesting. This one did not work. Huh. That one surprises me. I thought that one would work, but it's giving us 4 instead of 1. I thought that would be this factor right here. All right, well, let's jump back and do a couple base cases here. So for this calculation between C and D, if C is equal to D, then we can return 1. So that's an easy one. So that actually should fix our one test case here. Let's go back and try that. All right, so now we've fixed this one here. We've got our A and A, that's giving us the right answer. Okay, so that does fix one thing. The other one we can fix in here is if C is not in our mapping and D or D is not in the mapping, then we can return -1. Now, we might not need this one because it should be found here, but let's just do it anyway because it shortcuts a lot of this. All right, so now we need to fix this first case here. So this is where we have A and C. Now there's no direct mapping between A and C. They have to go through B because we do have a mapping between A and B, and we have a mapping to B and C. But we're only looking at the first level of mappings here. We're just looking at A to C, and that doesn't exist. All right. Because we're looking at just the first level of mapping, we're going to miss out on all of these more complex mappings. To fix that, we can do, it's a depth first search variation. Essentially, we'll grab what mappings do we have here. From those mappings, we can look at the mappings that they have. So we can keep going down this list of mappings to find deeper and deeper mappings until we find our result. All right, so to do that, we need to not just say for every mapping in C. If it's in D, well, that's great. But if it's not in D, it might have a mapping to something that is in D. So if it's in D, we'll continue down this route. But if it's not in D, we still might have a chance to find a further mapping down the line. So now we should actually do a recursive call on our calculation, passing in this key as one of the potential values, keeping D the same. All right, so maybe this key doesn't exist in our D directly, but maybe we can follow this key to its keys that might exist in D. So let's try a value here, and that's going to be equal to our calculation call on our key with our D. Now we do have to do a little bit of an adjustment here because whatever this returns will need to be adjusted by our current factor for our current mapping. So we actually have to multiply this by our mapping from our current C for this key. Now, if this value that gets returned, it could be a -1, meaning it didn't find that this key has any connection down the line, or it could be a real value. So we might need to keep track of whether or not this is a -1 or a real value. Let's have some result here. Set that equal to -1 to start with. We'll return this result at the end. And then in here, we'll just check. This result will either be the current result or the value, but only if the value isn't already a -1. Now, one final piece of this. We don't want to end up going in circles. This key might exist. For example, we have A can map to B, and then B can map to C, but then C might map back to B. We might end up going in circles. So we actually do need to keep track of which factors we've already visited. So we need a visited here. This will just be a set. So we can just say, let's see. All right, so in here, we will say that our C has been visited. So we're going to visit this variable. D is going to be our constant throughout. So we're constantly digging down, finding a factor with D. So we'll start with this C, we'll add it to our visited list. We'll go through all of its factors, finding a common factor if we can. If we don't find a common factor, then we'll do a recursive call, but only if we already haven't used this factor, K. So I'll have to check first if K is not in our visited. Then we will do this recursive call. So I think this should do it. Let's see how that goes. And I'm missing, oh, of course. So I do need to come back here and fix this up. So I need to add our visited, which will just be a set here. And then also in this recursive call will have to take our visited. Okay, let's try that. We're still failing. So what are we failing here? Looks like we're failing on our first. That's because this factor should be a divide by this factor. I completely messed that up. Now we're passing two of them. We're still missing out on this first one here. 6, 6. This last one, x divided by x. We're returning 1 because we have this factor up here. So let's move these around. Let's swap these. Let's check first if we have a mapping. If we do have a mapping, then we can check to see if they're the same. All right, that should fix it. So many errors on this one. Oh my goodness. Okay, this should be it. All right, so this seems to be working so far. Let's do a quick rundown of this. We're going through and we're finding a mapping from our values. So our mapping from A to B and from B to A, just by using our equations and our values. Then we're going through, and for every query, we're going to calculate the answer by calling our calculate function here, and then we'll add that answer to our result. The calculate function itself is a recursive function, so we're going to check to see if we don't have our values or these variables in our mapping. If we don't, we'll return -1. Then we'll check to see if they're the same. If they are the same, we can return 1. Finally, we'll go through and check to see if we can find this common factor K in both our C and our D. So if they share a common factor, we can just do our C divided by our D using that common factor and return that value. If they don't share a common factor, well, it's possible that future factors will be shared. So we'll take this current factor, make sure we haven't already used it by checking to see if it's in visited. Then we will go through and calculate the factor with k and d, passing in our visited, and then we need to multiply it by our sort of correction factor to map it back to c. Okay, let's see if we can pass all of the tests. And we get a wrong answer. So we're going to use this test case and see what went wrong. -4.5, these are very, very wrong. Notice that all the wrong ones are negative. These should be -1s, and we're passing back a negative something else. So it looks like we're doing something here where we're getting a -1, but we're actually doing some calculation. It's because of this. We should get the pure value back. Aha. Get the pure value back, and the result will be value times this mapping if value isn't -1. Otherwise, we'll keep it at -1. Let's try that. Okay, so that works. Let's try this one more time. We have 1 minute left. See if we can do this. And we pass with 1 minute to go. All right, we pass. We get 37% for runtime and 8% for memory. Not a great solution, but this one's kind of a struggle for me. I found this one really tricky. So check this one out. This is LeetCode number 399. Let's see, we had 1 failed submission and we had 1 passing. A lot of code here. That means there's a lot of places we can optimize. So check it out, see if you can do better. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.